let's continue and let's see what will happen if there are some unsaturated hydrocarbons. Let's stick to the simple one first, only unsaturated hydrocarbons, no functional group. So as we were solving few problems yesterday, we'll continue the same today as well. So one by one, I'll give you some structures to try to find out the names of those compounds. These are simple ones. You should be able to get all of them.
First one is pent-2-ene. Second is hex-2-ine. Third is but-1-ene, and fourth one is but-2-ene.
Yes. So you have to start giving them numbers from one side such that the
least
double bond is at the least position. And you can see the double bond is between position 2 and 3 in the first example, but you will take only second position.
Yeah.
Right? So this is pent-2-ene. Similarly, this one is hex-2-ene, this one is but-1-ene, and so on. Okay, let's increase the complexity a little bit and see. Few more examples. Yes. What do you think is this?
1, 2, 3, 4, 5, 1, 2, 3. Yeah, it is 4-methyl pent-2-ene.
4-methyl pent-2-ene. So you have to start the numbering from this side. So if I do it from this side, it will be wrong.
Yeah.
Right? Because as I have told you yesterday, functional
Double
group,
bond will give preference,
multiple bond, and then substitutes. This is the priority which we have to follow always. Let's include a cyclic compound. What do you think will be this?
Hex-1-ene, cyclohexone.
Okay. See, cyclo X, obviously this is position 1, 2, and so on. X1-ene. Now here, if it is a cyclic compound, and if there is only one ene, so the thing is it possible to have a compound whose name is cyclohex-3-ene? Is it possible?
No.
No. So this number is not required. This position is not required. When there is only one double bond in a cyclic compound. So ultimate test is what? You try to see if the position makes any difference or not. For example, here I have given you an example. Will it be possible
to
have a compound like this? No. So that means this position is not required. Right?
Okay.
Sometimes it will be required, sometimes it won't be required. Right? So you will have to be careful about that. So let's see another compound. So if there is a multiple bond only, and even if there is multiple bond plus some other substituents as well, but we know that if there is a multiple bond and other substituents, Between multiple bond and substituents, multiple bond will have the highest priority. So that will always get the first position. So if that is the situation, that is multiple bond is anyways getting the first position in the cyclic compound, then there is no need to write cyclohex 1ene or cyclopent 1ene or cyclo. You understood,
Okay.
right? So what will be the name of this compound?
So do we write here 1 methyl? Just write methyl hexene.
Hmm?
Yeah.
What was
Sorry,
it?
cyclohexene. So do we write like 1 methyl here because it's obvious that it will be one? So we just write methyl cyclohexene.
This 1ene, right? This is only for suffix. Prefix, right? Prefix, the position is must,
Okay.
right? But suffix means the main name, right? It's like the main name of this compound, the family name. And if it is a double bond, we know that its position will be this. If it is just like carboxylic acid, if there is a carboxylic acid, there will be C double bond OOH in the end always. So we never write pent one carboxylic acid or pent one oic acid. We don't write that, right?
Yeah, yeah. Okay.
It is similar to that. So uh, if it is the only double bond, its position is fixed, that it will be position 1.
Okay.
Right?
So 1 methyl cyclohexene.
So this is 1 methyl cyclohexene, correct. So this is the position 1 and this is 2. So it is position 1. So it will have the number 1. Okay, the methyl is at number 1 position, right? If you give this double bond is still at position 1, but that will be wrong. The green scheme is the wrong scheme of numbering.
Yeah.
Okay, let's see a few more examples in this. What if you have double bond here and the methyl group here?
Two methyl
What I
cyclohexene.
ask, 1 minute. Um, yes, go ahead. What was your answer for this?
1 second. Yeah, it will be 1, 2, 3. So 3. Uh, that numbering should be wrong, right? Isn't the other way around?
Yes. So left and right, which one is correct?
Okay. Oh yeah. The right side one is right.
Correct. So this is wrong. This is right. As per this, it will be
3
2-methyl
methyl.
cyclohexane, but the correct
Yeah.
name is,
So
as per
here
this.
3 methyl cyclohexene. Yeah.
Okay. So that's correct.
4-methyl cyclohexene.
4. Correct. Okay, so that is right. Let's move to, let's now try to make it more complicated by adding more substituents. Right now we had only one substituent. So let's have multiple substituents as well as a double bond. So let's copy this. Yes. So what will be the name of this compound?
Oh, this is actually adipic acid, right?
It's not an acid.
Not acid, sorry. Oh yeah. If there's a COH, then it becomes adipic acid, right?
Mhm.
Yeah. Yeah, this will be 1,2 dimethyl cyclohexene.
Dimethyl
Hexene.
cyclohexene. So one of the position is 1, another position is 2. Then it can go like this. Okay. So next one, let's say it has a substituent like this.
Yeah. One, two, three. Yeah.
First of all, see, you will have to go systematically. You
Yeah.
can do it, but still, first number this. Then you see that this is a complex substituent. So now you find out that there is a complex substituent here.
Yeah.
This is position 1 and this is position 2. So first you name it here itself, this complex group. So this will be what? 1, comma 2,
1,2 dimethyl.
dimethyl, ethyl,
Okay, ethyl.
right? Yes. So now this complete thing, this complete group is at position 3. So now tell me what will be the name?
So is it 1,1?
Where? No.
1,1
It is 1, comma 1.
Yeah. And then so it will be 3 bracket 3 dash bracket 1,1 dimethyl ethyl cyclohexene.
Done. Okay. Now, what if we have two different substituents, say for example a methyl group, diethyl group.
Yeah.
So
So
now the thing is here, if you write 1, 2, or if you write 1 here and 2 here, which one is the correct one?
the green color.
The green one is the correct one because
Ethyl. Alphabetical.
yes. So because there is no difference, both the numbers will be 1 and 2, both the positions are 1 and 2, there is no difference, there is a tie. And if in such cases, we break the tie by alphabetical order. So I think now the name is simple. You can
Yeah.
easily write the name, right? So it,
One. Yeah.
1.
1 ethyl, 2 methyl cyclohexene.
Okay. Done. So this thing, this Now, what we are doing right now, the nomenclature and of such complex cases, right? This is very important because it helps you in determining the structure also. So when we'll study the reverse of this, that is from the name, from the molecular formula, how to find the structure, that is again very interesting and very important.
Yeah.
So again, before you proceed, let me ask, there are two possibilities. One is this, or other possibility is, I think,
This
this
is
one,
wrong. Yeah, that is
two,
right.
3, 4, 5, and 6.
Green
So
color is right.
green color is right. So if you see the green color, the substituents, see whether I take the red one or the green one, the multiple bond position is what? One
One
in both.
case. Yeah.
Now coming to the substituents. If I take the red one, it is 1 is
1 and 6.
1 comma 6, and if I take the green one, it is
2 and 3.
2 and 3. So which one is correct?
Least number, least priority. So whatever 2 and 3 is lesser than 1 and 6. So 2 and 3.
See here itself, there is a, you can break the tie here itself, right? In the first spot itself, 1 and 2. There's no need to go to 6 and 3.
Oh, okay.
Right? So which position, the first, if you see the red one, you are giving first position to the subsequent, while in the second, the green scheme, the first subsequent is at position 2. So the correct one is the red one. So this is the
Okay.
basic in case of multiple substituents. So if there are multiple substituents, you should you should select that numbering scheme in which the lowest numbers are used. So lowest number is out of 1 and 2, it is 1 which is the lowest one,
Okay. Okay.
right? Now the problem is in many books you will find lowest sum.
Hmm.
That is wrong.
Okay.
That is not something which is given by IUPAC. That is the only in few books you will find. That is not the real law or the right. That is not prescribed by the IUPAC. So the correct scheme is this 1 and 6. Now you tell me the name of this compound.
Uh, 1,6 dimethyl cyclohexene.
Done. That's correct. Okay. Let's move to next question. So you don't have to worry if you make mistakes here, as I always say, right? This only gives us an idea about this. The main objective of this exercise is to clear your concepts. So don't worry if you are getting some few answers wrong, right?
Yes, sir. Yeah, this is 2, 3. Yeah, it is 1 methyl 6 propyl cyclohexene.
Correct. 1-methyl, 6-propyl cyclohexene. Okay. So yesterday you told me, right, you had few doubts in these cyclic compounds. So is it helping you in that, these exercise?
Yeah. Yeah. Hmm. 5-bromo, 4-chloro, 2-iodo cyclohexene. One second. 1, 2, 3, 4. Oh no, no,
See,
it's not. No, it's
you
not.
will be
It's not.
giving number one to this, right? There's no doubt in that.
Yeah.
Okay.
That. Yeah. Yeah. Correct. Bromine. Yeah. It is better if you put the other way around. 1, 2, 3, 4. 3, 4. 1, 2, 3. Yeah, this is right. 1, 2, 3.
Right. Other possibility is what? Other possibility is that you give what, position 1 to this, but
Yeah.
that
1,
you
2,
won't
3.
do. Position 1 to this and move in this direction. Obviously, that won't be do. We won't be doing that as well. So here you have one. I mean, the positions are 1, 4, and 5. So that is the correct position. That is the lowest numbers actually. So yes, while writing, how are you going to write?
4, 5, 1.
Yes, while writing, it will be 4-bromo because that
4
is
bromo, 5 chloro, 1 iodo, cyclohexene.
done. Let's see few more examples with complex substituent. This we have already seen, right? Now let's say
Yeah.
there is one more substituent. So are both of them complex, or one of them is complex, another simple?
Both are complex.
Both are complex. So as I said, first thing what we are going to do, name the substituent.
Right,
That is
substituents.
how it
Yeah.
will be easy. So first
The
one is
up one is 1, 1 dimethyl ethyl. Other is 1 methyl ethyl.
okay. Now we know that one
Yeah.
of these double bonds, one of the carbons between which shares the double bond, that will get position 1. But then if I give this position 1, this will be number 2. If I give this position 1,
Then you
obviously this
can.
will be number 2. So which one, or what should be
Yeah.
the,
1 second.
so as you can
Yeah.
see, it
It
is
should be.
symmetric.
Yeah.
So this is dimethyl and this is methyl,
Hmm.
right? So D comes first. So we should
Yeah.
prefer what? We should prefer 1,1 dimethyl. That is this one. This one should be preferred. So obviously I'll have to start from position 1 here, 2 here, and 3 here, right? So that this gets position 6.
Hmm.
Any doubt in that?
No.
No. So the name of this compound will be what?
3 3 dash 1 comma 1 dimethyl 6 dash 1 methyl cyclohexene.
Are you also writing these names?
Yeah.
Okay. So that is the correct name. Okay. Let's see one more name. Double bond here as well. Okay, so now the substituents are simple, but the situation is little complicated as now you have two substituents and two double bonds. So
Yeah.
as soon as you have two double bonds or multiple instances of multiple bonds, then you will have to give position to those multiple bonds as well, so that we
Yeah.
can identify the position of those multiple bonds. Yes.
The answer is 1 ethyl, 3 methyl, uh, 1 second, 1 methyl, yeah, 1 comma 2, 3 comma, I don't
One,
know how to name both of them.
no, I will do that. One ethyl, three methyl. I guess here you don't have any problem, right? So you
No.
started from this. This was given position 1. Why? Because this is ET and
Ethyl,
E,
yeah,
so E comes first. Position 2, obviously 3, because if you come from the other side, this will be having larger position. Okay, done. That's all. So 1 ethyl, 3 methyl, those are the substituents. After that, you will have to
cyclo,
write the cyclo. So as we have seen earlier also, this part, the substituent part, this is one suffix, sorry, prefix, then this is the second prefix, and then you have the root word. So the root word will be hex,
hexane, yeah, hex,
hexane. But here it has two enes. So that's why we will write hex 1 comma 3 diene. Right now, in normal English, right, English grammar or English word formation, you must have seen that two words together, two consonants together, it doesn't go well.
yeah,
So what
hexa,
we actually do is, yes, we actually add an extra vowel here, that is a. So this is 1 ethyl, 3 methyl, cyclohexa 1,3-diene,
yeah, okay,
right? So this is your root word and this is your suffix. Right now we have not seen the secondary suffix, that is the functional group. Anyways, I hope you understood this,
yeah,
right? Except of adding an extra vowel only if there are two consonants together. And there
yeah,
will be situations when there will be two vowels together. So in that case, you will have to omit one vowel. We will see that as well. We will see such examples as well. Okay, so for example, if you have a compound like this, a double bond here and a double bond here. So this is bute, not bute 1,3-diene. If you write that, bute 1,3 diene. So that is wrong. You will have to write buta 1,3 diene. This is the correct one.
Okay.
Right? The difference is this A. Right? An extra vowel added between two consonants. Okay, so you can expect such. So this is an example where there can be multiple bonds. Let's take one more example. That is, okay, what if there is a double bond and a triple bond?
Preference to triple bond.
Preference will be,
Triple bond.
and what does that mean?
That means the double bond will be a substituent.
Okay. Mhm. Okay. See, as we have already seen that functional group, first preference, then multiple bond, then substituent. We have never said that in multiple bond also there are two, or if there are multiple bonds or different types of multiple bond, then there will be uh, two different priority. We never said that. So both of them will have same priority. And whenever you have a tie, that is when in the last you have a tie, you are not able to break the tie, then you just write it in alphabetical order. It is never double bond versus triple bond. It is never like that,
Okay.
right? It is just the alphabetical order. You just write it in alphabetical order. So now here you have a double bond. So double bonds means in, triple bond means I. So which one should get preference?
E.
So while numbering itself, you will start. I mean, here there is no doubt that this will be the numbering sequence. It won't be opposite,
Yeah.
right? If you write it in this green sequence, it will be wrong because multiple bonds have same preference. So the red scheme gives number 1, 4, and the green scheme gives number 2, 5. So obviously the green one is wrong and the red one is right. Okay, and while writing it, how we are going to write? So there are total 6 carbon. So hex, right? These double bonds and triple bonds, they are never treated as prefix. They are never treated as substituents. They will be always treated as suffix or the family. They will be never treated as the prefix or the substituents. So hex, after that, as you can see before hex, the root word, there is nothing. So it's not a prefix. Hex, 1 in, and now you see
N.
1 in generally has an E as well at the end. So I'll write that for you first. So hex 1 in and 4 in, right? But if you see the thing which we have discussed earlier, that if you have just like here, two consonants are together, then you insert a vowel. And if you have two vowels together, you will have to omit one of them, right? So here, this E and Y, sorry, E and Y. So both of them are not vowel, but Y, how are you going to pronounce it? Ein. So when we say ein, so this is a vowel sounding It's not vowel, but it's vowel
Yeah.
sounding.
Sound.
And that's when you will have to remove this. Sorry, the first one, the E, has to be removed. So the correct name here will be hex 1 in 4 I. Hexenine. So that, see, when you have to check, right, whether vowels or consonant problems, right? So you omit the numbers and then you try to read out. So now you will be reading it correctly. Hexenine. Clear?
Yes, sir.
Okay. Let's see one more example. Okay. A double bond here, a double bond here, and a triple bond here.
Yeah. Wow. Hex.
So first tell me the numbers.
One.
Shall I start numbering from left or right?
Left.
Left. See, if you start from right, even then you will get the same. 1, 3, and 5. If you start from left, even then you are getting 1, 3, 5. So whenever there is such a tie, you have to break. And here you can see that only multiple bonds are there. So double bond will get the higher preference. Okay, go ahead. Next.
Hex 1, 2 die N.
1, 2 or 1, 3?
1, 3. Sorry. Die N. 5 I.
Correct. And here 1A. Hexa.
Yeah.
X and D.
Yeah.
Okay. Okay, so I guess you understood.
Yes, sir.
Let me give you one more example just to check. So first, let me ask you directly the numbering. Which one is correct? The red one or the green?
Green.
The green one, because in green scheme it is 1, 4, and in the
Yeah.
red scheme it is
2,
2, 5. So the green one is correct and the red one is yes. Now I think you can name it easily. Tell me the name.
yeah. Yeah. 1, 2, 3, 4, 5, 6. Yeah. Hex. Hexa.
Okay.
No, not hexa. Just hex. Hex 3N.
3, there is no
1,
3.
9.
Either 1, 4 or 2, 5.
Hex 4N 1 9.
Hex 4 N 1 I.
No, I
Hexagon.
said 4. Hex 4N 1 9.
Correct?
There's a lag. Yeah.
Hmm? Okay, so as you can see here, both are multiple bonds. In case of multiple bonds, when there is a mixture of multiple bond, that is, there is a double bond as well as triple bond. In that case, you have to um, keep in mind that both are multiple bonds. It's not double bond or triple bond, right?
Yeah.
Numbering should be given lowest number to double or triple bond if functional group is not present. So numbering has to be lowest. That is what you have to make sure, irrespective of double bond or triple bond, right? And while you are writing, you write in the alphabetical order. That is, in comes first, then ein. That's all. So these
Yeah.
are the 3 bullet points for this. Okay. Now, let's move to the next example. Yes.
Yeah. The answer is one. One second. One, two,
First, tell me from which direction you should start.
one left.
This should get 1.
No, wait. One second. One second. 1, 2, 3, 4, 5, 6, 7, 8. No. This the right side one should be 1. Yeah.
Okay. So there is no doubt in this. Okay. Now go ahead. Now, obviously, this is the substituent,
Yeah.
right? So what will be the name of this substituent?
Ethanol.
Ethenide,
Yeah. Ethanol.
right? Because this is coming from ethene. So that's
Yeah.
why this will be ethenide. Good. Now you tell me the name. So first, the substituent.
Yeah. So 4 ethanol. 4 ethanol. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Oct 1 N 6 ein.
Correct. Okay. Okay, so that was about the compounds which have multiple bonds, and we have also seen compounds where multiple bonds are there, and even the substituents are having multiple bonds. I mean, this is one of the examples we saw where the substituent is also or substituent also contains a multiple bond. So like that, you will have to solve questions if you get something like this. Let's solve one last problem today, and then I'll also give you some more problems for your homework, for your own practice. Yes.
One,
See, this is just to confuse you, right?
yeah, one,
That
two, three.
means there is a carbon.
2 carbons. Yeah.
Correct. Yes. So now tell me.
You start numbering from the left.
From left. Okay.
And substituent, that is substituent, the triple bond substituent, because the main chain has 7 carbons.
Main
And
chain has 7 carbon. Okay.
so
Okay.
it
So
is
do you think the main chain is 1, 1, 2, 3, 4, 5, 6, 7? Right? This is your main chain. But what if I say 1, 2, 3, 4, 5, 6, 7, 8?
1, 2, 3, 4. Yeah.
Right? So first you have to select the main chain. Actually, you have to select the longest chain. Yes. So this is the longest chain. Now I have to start giving them numbers. So if I start from this side, it will get position 2. If I start from this side, even then it will get position 2. Right? Then I have 3, 4, 5. And if I start from this side, I will have 3, 4. So the red scheme gives me bonds at position 2, then a substituent at position 4, then another bond at position 6. So here what do I get? I get 1, sorry, I get 2, 4,
6.
6.
Yeah, 2, 4, 6.
And in the orange one, I'll get 2, 3, 4, 5, and 6. So I'll get 2, 5, 6. So which one is the correct one?
So red.
The red one. So 4 is the tiebreaker, 4 and 5. So red one is the correct one. I hope you understood, right? Okay, so
Yeah.
now let's move ahead and find the name or write the name. So first, as we have seen earlier also, this is your substituent. So this is nothing but ethanol, just like we have seen above.
Yeah.
So the name is
4 ethynyl 6 no 4 ethynyl 6N 2I.
right. Okay, so that is correct. Now, based on this, I'm going to give you around around 49 more structures. Okay, so those structures won't include any functional group, right? And then I'll also send you few questions based on functional group. So questions based on functional group I'll send later, but tonight I'm going to send you around 49 structures having no functional group, but all of the concepts which we have seen till now. That is simple chain, having multiple substituents, having complex substituents, having cycles, and having multiple instances of multiple bonds, right?
Yes.
So those I'm going to send you now. You just go through that, and by tomorrow morning, first half anytime, I'll send you the exercise for functional groups as well, so that when we will solving questions, if you have, we'll go through your answers in tomorrow's class, and that will complete the nomenclature with functional group as well. So once nomenclature is over, then we'll move to physics.
Okay.
Okay.